Fireworks. Everyone loves them. They're spectacular and they're beautiful. But have you ever thought about what's in them? Or what the chemistry is that makes them do what they do? We got special access to the military research laboratories of the Ministry of Defence and persuaded top explosives experts to reveal the secrets of firework making. These scientists will show us how they make controlled explosions and how fireworks get their colours, sparks and whistles. You won't see any of the following demonstrations in any classroom because they're too dangerous.
The main purpose of fireworks is that they actually burn. They don't burn as fast as rocket propellants or even high explosives. They burn pretty slowly but faster than when you're actually lighting a match or burning a piece of paper. So the basis of fireworks is down to some chemistry, some physics and some artistry.
Fireworks are all about combustion, the burning of a fuel in the presence of oxygen. For instance, sugar is a fuel, but it won't burn on its own. However, if we mix it thoroughly with a substance that's rich in oxygen, such as potassium chlorate, it's a different story. The potassium chlorate oxidizes the sugar in a violent reaction, and a lot of energy is released all at once. Of course, fireworks don't use sugar. They have charcoal as their fuel source.
Here I have some charcoal, the fuel, and the oxidizer, which is potassium nitrate. What we're going to do, we're going to mix these two together and let's see if they burn. As you can see, it's trying to burn, but the reaction is very, very slow and it's actually gone out now. So this fuel and oxidizer doesn't actually burn. What we need to add to this fuel and oxidizer is another ingredient, and the third ingredient is called sulfur.
When we ignite this charcoal, potassium nitrate and sulfur mix, the sulfur will melt, pulling the two powders together and lowering the ignition temperature. Result: the mixture here, known in the trade as a composition, ignites very quickly. The burn rate is very fast and a lot of smoke and heat is produced. This composition is the basis of all fireworks and is better known as gunpowder. So that's the basis of fireworks. But how do we get the spectacular effects we all love to see? The answer is, of course, chemistry. For instance, we can change the colour of our firework by adding a metal salt. When a red colour is needed, a compound containing strontium is added to the composition. A copper salt gives a green colour, while sodium gives an orangey yellow, and so on.
As well as the pretty colours, we can also make coloured smoke by adding another ingredient to our basic composition. This is a smoke bomb.
This smoke bomb will self-destruct in 15 seconds. The firework produces great clouds of smoke. And again, the colour can be changed by adding a metal salt.
Another type of effect we can have in a firework is to add metal powder. Here I have some aluminium, and this aluminium is inside this firework. What happens is that when the firework actually burns, it shoots out hot gases. These hot gases heat up the aluminium, which burns with a white flame, and it looks as though sparks are being shot out of this firework.
But fireworks aren't just about the visuals. Sound is very important too. We can heighten the effect of pyrotechnics by adding a whistle or scream.
This is a whistling composition. The way it works is that the fuse ignites a composition inside this cardboard tube. And as the composition is burning away, on the surface the small crystals are exploding. This causes the tube to vibrate and you get the whistle sound.
The reaction is so fierce that the sound waves produced are spectacularly loud and piercing. part of a fireworks demonstration, whistlers are very effective. So far, everything we've looked at is ground-based or static. But think fireworks and you immediately think of rockets racing into the sky. So how does that work? Jackie's colleague Alex Contini explains.
We've got a fake rocket here that just shows you how it's actually made inside. So you have a cardboard tube containing the lift composition.
Inside the rocket is a charge of gunpowder, which is hollowed out in the centre to allow downward thrust from the hot gases as they burn. The rocket is stabilised by a fin, or wooden stick to you or me, at the base. A basic rocket like this is simply a delivery mechanism for whichever effect we want to get up into the sky.
Once the combustion has actually reached the top of our lift tube, there is usually a tiny little delay which sets fire to the payload, which usually sits right on top of your lift tube. There is a burst charge inside that will ignite the stars, the coloured stars and the other effects which we may expect inside the payload. So we might get a burst of blue or a burst of green.
As we can see, gunpowder burns very fiercely. But under the right circumstances, gunpowder doesn't just burn, it explodes.
What we've prepared here is a small cardboard container with 1.5 grams of gunpowder. You've seen the combustion of 1.5 grams of gunpowder unconfined. Let's have a look at what happens when we give it some degree of confinement. The way we can ignite our charge is by means of a small electrical igniter.
The charge, which we can see here inside the cardboard tube, is set off by passing a tiny electric current through the gunpowder.
If I just connect the terminals and close the lid of the box, we are ready to try out. Right, I'm going to connect the red terminal to the red terminal. Stand by, firing now.
Gunpowder is an old-fashioned and fairly inefficient explosive. You can see the sooty deposits of unburned charcoal. Many modern stage and TV effects now use flash powder.
This is flash powder. Flash powder contains a metal powder as a fuel instead of carbon, so it's quite similar to gunpowder, but this metal powder burns at a much higher temperature, a very fast rate as well, so the whole reaction is far more violent. Firstly, I need this stick so that I'm away from the actual ignition because it's been very, very hot and very fast.
Flash powder is very much more energetic. So what happens when it's contained?
So now we have some flash powder inside this box. As you know, flash powder contains a metal powder instead of charcoal, and it's a much more violent reaction.
Right. As you can see, it's pretty much the same setup that we had before for the gunpowder. So again, a small cylindrical cardboard tube containing this time only 0.8 grams of flash powder. We really didn't want to put in 1.5 grams because you will see what happens with only that small amount. And let's see. Stand by. Firing now.
To prove that the scientists really knew their stuff, we challenged them to dissect a rocket and predict what an identical rocket might do when ignited. Alex starts on the nose cone. He has to be very careful, as excess heat from the friction of the saw could ignite the firework. Will he be able to work out what's in there? This is something that's totally illegal outside of this lab, and quite rightly. Dismantling fireworks is hugely dangerous. Do not do this at home. Ever.
Just pour out a bit of this mixture you can see in fact that what you have is quite a high number of these pellets, and they are literally swimming in a greyish powder which is known as burst charge. Once that's lit, of course, the stars will be lit, explosion, these will be lit sequentially and get the full effect.
I think when you burn these stars, they're going to burn with a coloured flame. I don't know what colour it will be, but we'll try and burn one and see what colour it's actually going to give.
That's a good idea. Yes, let's do it. Right, I will actually take this big one here, and standing well away from that, perhaps here, let's try and light one and see what colour it gives. Again, don't try this at home. Well,
Red.
I saw red.
So that means that it contains that metal salt containing strontium, and they probably will all burn with a red flame.
Right, so look what we've got here. We've got tiny cardboard tubes with some priming composition. Now, a priming composition is something which ignites very easily from the burst charge. Very likely these will be small whistlers, I think.
I will say definitely.
Definitely.
You've got a white powder here.
That's
it's not
bentonite.
black. Yes, so it's not the gunpowder, so this will most likely say be a whistler.
A whistler, yeah. Let's try a whistler now. We'll need a taper for this one because it can be quite energetic. So we're going to distance ourselves a bit, since we don't know what effect this little fella will produce when it's down on the ground rather than up in the sky. Well, that was definitely a good whistle.
That definitely was.
So the prediction is there'll be an aerial display giving us red stars followed by a series of screamers. But have they got it right? There's only one way to find out. Other than reading the label, of course, but where's the fun in that?
So the proof of the pudding is in the eating. Let's go, Alex.
Spot on. The rocket behaves exactly as planned, right down to the screamers. There's no doubt that Jackie and Alex know what they're doing, and they've had years of experience handling these sorts of materials. Fireworks are undoubtedly fun, but to keep them that way, please enjoy them responsibly, or the consequences could be tragic.